All right, this is the start of Module 3. We're going to be talking about formula masses. But first, I wanted to show you the importance of writing formulas correctly. And this is a picture of a tattoo on Jennifer Lawrence's hand because, according to this article in Vogue, she always wanted to remember to stay hydrated. So she wanted to put H2O on her hand. And she noted that she should have Googled this tattoo first that's going to be on her body forever, because if you notice H2O, she put a superscript up here, and H2O, the 2 should be a subscript. So even though Googling doesn't always give you the correct answer, maybe before you tattoo it, you would look. So we're going to jump right in and start talking about formula masses. All right, so jumping back in, we're going to be looking at our periodic table, and this is definitely a resource you're going to want to print out and have handy so that you can have it at your fingertips to use. So if we were to, let's say, look at nitrogen, I'm going to highlight nitrogen over here on the right. If we were to look at nitrogen, and we know that nitrogen is one of our diatomic molecules, so it's N2. That's how it exists naturally. Remember, not by itself. Remember, we talked about Brinkelhoff, and N is in Brinkelhoff. So we know that nitrogen has a mass, where it says here, of 14.007 atomic mass units, which we label U. Now, we know that's what one nitrogen weighs, but N2, the formula N2, tells us that there's 2 nitrogens. So nitrogen plus nitrogen to give us 2 nitrogens, right? So I need to take my 14.007 and add 14.007. I need 2 of them. So my formula mass for N2 is going to be 28.014 atomic mass units. So all we need to do is look at, okay, 1 atom of nitrogen, the periodic table tells me. Just like the periodic table would also tell me 1 atom of fluorine has a mass of 18.998. 1 atom of helium is 4.003. So if we need more than 1, we need to look at this subscript. So it tells me I need 2. So I need to add that 2 nitrogens together to get that answer. So if we were to go over here, this is pretty much what it's telling me. N2 tells me that I have 2 nitrogens. We know that 1 nitrogen's mass is 14. Why did they get that number? Well, we need to cross that off because that is not correct. 14.007. So we need to make that 14.007, and so that would be 28.014 U. Okay, now we're going to do the next thing, for H2O. And this tells me that I have 2 H's. So looking at this compound, we have 2 H's and 1 O, which tells me that these little white guys here, these are my H's, and my 1 O would be up here. 2 H's and 1 O. So we're going to look back at my periodic table, and we're going to look at hydrogen up here in the top left. We see that one hydrogen has a mass of 1.008. So we see here 1.008 for hydrogen. And let's look at my oxygen over here on the right. Notice it's atomic number 8, and 1 oxygen is 15.999. So we see here 1 oxygen is 15 point, we're fixing that, 999. So I need to, this is what one hydrogen is. I need two hydrogens. So I'm going to say 2 times 1.008. And I'm going to add that to my one oxygen, 15.999. And you should get 18.015. Notice that I'm not rounding, I'm not truncating. I'm taking what my periodic table gave me for the mass, which was to 3 decimals, and I'm leaving it to 3 decimals. So we don't need to do any rounding. Now, there are some periodic tables that might have, you know, oxygen or hydrogen might be 1.009 on one. That thousandth of a decimal point, if you're off, if your number is a little bit different on this thousandths, again, depending on what periodic table you're using, it's okay to be off by a couple of thousandths. All right, let's look at another example, CO2. So we know that carbon, again, if we were to look back on my periodic table, carbon right here, number 6, we'll highlight this guy, is 12.011. So CO2, again, oxygen is 15.999. We're going to go back here, 12.011, 15.999. Make that a 9. So this tells me that I have one carbon, right, because there's no subscript after it, which means that there's one, and then 2 oxygens. So I need to take my 12.011 plus, and then I need to do 2 oxygens, 15.999. Now we just need to plug it into the calculator, and we should get 44.009 atomic mass units. All right. I would like for you to pause here. Don't go all the way ahead, but I would like for you to pause it and try to figure out how many atoms are in calcium phosphate. See if you can figure that out. So if we look at this, we can see that Ca, there's a subscript 3, so that tells me that I have 3 calciums. And then I have a parenthesis, PO4 with a parenthesis 2. So in one phosphate, there is 1 P and 4 oxygens. But this tells me, this 2 subscript says that I have 2 phosphates, meaning I have a PO4 and then another PO4. So a total of how many P's? That would be 2 P's. So this 2 distributes and would tell me that I have 2 phosphoruses and 2 times 4, or if I added these 2 up, 4 and 4 is 8 oxygens. So now we need to go back to our periodic table and look up calcium, phosphorus, and oxygen. From up above, we know that oxygen is 15.999. Then we just need to look up calcium, which is right here, 40.078. And phosphorus, which is over here, 30.974. And then we need to look at, okay, we've got each of the individuals, but now we need to multiply by how many atoms there were. So we need to multiply this times 3, multiply this times 2, multiply this times 8, and add it all up. Let's see what we get. All right, hopefully you got 310.174 atomic mass units. All right, one more to go. So we have aluminum sulfate. Again, similar to the calcium phosphate, there's some parentheses here. We're going to need to do some distributing. I would like for you to try to solve this one. So why don't you pause it And if you think you got it all solved, you can fast forward by, I don't know, a couple seconds, a minute to check your answer and see if you got the right answer. All right, so let's look at this. This aluminum, I've got 2 aluminums. And then this tells me I have 3 SO4s. That's what that means. So I would have an SO4, SO4, that would be 2, SO4, that would be 3. So I have a total of 3 S's. Again, that 3 distributes. And then if that 3 is distributed to that 4 oxygens, I would have 4 times 3 is 12. Or we could look at this, 4, 8, 12. So 12 oxygens. So then what we're going to do is look up the mass to aluminum. Should be 26.982. Sulfur is 32.066. And oxygen is 15.999. Multiply by 2 times 3 times 12. Add it all up and we get 342.150 units. So make sure that you have your periodic table handy because we are going to be using formula masses from here on out.